This is the 2019 ordinary level B2 question looking at axonometric projection. So just having a look at the question. The graphic on the right shows a candle holder and a candle. Figure B2 shows an incomplete isometric projection of a similar candle holder. The elevation and plan of the holder are shown in the required positions. Part A, draw the given equilateral triangle ABC and the axonometric axis X, Y, and Z. Part B, draw the elevation and plan positioned as shown. Part C, draw the axonometric projection of the body of the candle holder. And Part D, draw the axonometric projection of the cylinder hole, the circular hole on the top surface of the candle holder. So now, having a look at our question page, we are going to set up the question as it's given in the question. And Part A is to draw the equilateral triangle and the axonometric axis. So I've started by drawing my axis. There are 30 degrees. It's located approximately halfway up the page, just to give us space for the plan and for the elevation that's going to go over here. We're told that the side length of the line AB, which is part of the equilateral triangle, is 100 mil. So it's going to be 50 millimeters either side of the vertical axis line. And when drawn accurately, they line up with each other. They're horizontal here. What we need to do next is find the lines going up along this way. So they are drawn so that they are perpendicular to this line. So this line is at 30 degrees, so the line coming out of that will be at 60. This line here is also at 30 degrees going in the opposite direction. So again, a line perpendicular to that would be at 60 degrees. So that completes the equilateral triangle and the axis AB and the X, Y, Z axis. In the next part of this, we now need to draw the elevation and plan positioned as shown. So the plan is going to go down here directly below it. So let's do that first. So lines projected down. Pick a line, horizontal line down here somewhere. It's drawn parallel to this one. And in that, we're going to draw a semicircle. So point our compass on the point where our axis line intersects the horizontal line that we've just drawn. Pencil out to the side, and we draw a semicircle. Now, inside in this, we join the 3 points where the 3 points in the semicircle are cut. This is 1, 2, and 3. So this gives us the axis that it is going to sit into. So we can draw 1, and this line here also. So this is where our plan is going to sit. So I'm going to draw the plan now, and it's based on a rectangle that's 60 by 60. And then the inner part of that is based on 40. So the inner square is 40 millimeters, and we can see that information up in the elevation view, the elevation up in the top right. So that 40 there that shows is where that's coming from. Now, so that's most of the plan. Final part is just to find the center of our circle. So join our diagonals. This point here is going to be that center. We're told it's a radius of 15. So let's draw that circle. And that completes the plan for us. So it was drawn at 45 degrees, which this angle in here will be. So this is 90, 45, 45. And next what we're going to do now is we're going to draw the elevation. Elevation is set up in much the same way that the plan was. Going to extend these lines out at our 30 degrees. Line drawn perpendicular to that. So now we're going to draw in our semicircle. So again, touches both. So it touches this point and this point, so it's halfway along the line there. And in this case, for ordinary level, it's always where this central axis divides it. So again, taking line from here down to the center to that point. Same going the opposite direction. This is the axis, this is the edge view of the axis that I'm going to draw my object sitting into. So again, this distance out along here is 60, as it's the elevation, it's based on that 60 millimeter square. I have heights up here of 20, which is for vertical pieces, and then it's another 45 to the very top of it. I'm also going to find the central axis running up the middle of it. It's going to be handy for a circle in a while and a few other pieces. So using our sliding set squares, going to create the lines necessary for this. Brings it up on the right side of it, and then the central axis also. So I can darken in a few bits and pieces here now. Now we're told that the top piece up here is 40 millimeters wide, so that's going to be 20 millimeters either side of the axis. So we can join those points now down to the corners that we just darkened in. Finishing off the top piece, just giving me the top edge up there. Now that's almost it. We still need to put in the circular hole cut out of the center part here. So that was radius 15, so it'll be 15 now measured from either side, from the center. And that comes down a depth of 35. And hidden detail. So that completes the elevation and also completes part B, so to draw the elevation and plan position as shown. So the next part of this is to draw the axonometric projection of the body of the candle holder, so that's taking all of it except the circular hole, the cylindrical hole taken out at the top of it. So we're going to be projecting the same points from this view and this view, locating them in here and then forming our 3D block. So the elevation is essentially looking in this way at our object. So if I have a point here on the right hand side of it, it's going to be the right hand side of it here. If it's the left hand side of it, it's the left hand side of it here. So start by projecting lines down and in. I'm going to find that side of it now up in elevation. So that gives me that point here, and this one is here, which is where it crosses that point on the axis anyway. If I find the top of that, so up to 20 millimeters, that's also going to be in line with that same edge. So I just need a second line to come down from there. And I now have this face of it here complete, so I can darken that much of it in. Going to be the same going back on the opposite side. So I already have this back line brought down. So finding this corner up in the elevation, it will be where this line comes back to meet. And bringing the high point of that down also gives me here, which is going to join to this point. So that's the very bottom part of this, the widest part of this drawing. The next part we're going to look at drawing the top face without the hole up on top of it, and then we'll be able to put the sides into this. So I'm going to take this top front corner and project that down along. So that is looking at this line along here as an edge view. So that gives me 2 points. That's going to give me this point here and also this one. So that back along further is this point here. So on the line down along here, front point, back point, give me 2 points there. Going to have the same coming from the opposite side. So this point, project that one down. That is going to be this one and this one, the corresponding points, because as I said, we're looking at this way at it. So this corner here is an edge view of this line looking back, or point view of this line. And we'll do this one here at the back. Give me it there. So we can complete this square up on top now. That completes the square up on top. Now, for each of this, we can see in our 3D that there's lines sloping down. Those lines join from each point down to the lower corresponding point. So that's this one going vertical here and here. Now that completes part C, draw the axonometric projection of the body of the candle holder. So that draws the entire block part of it without the cylindrical hole up on top. So that's what we're going to look at now, drawing the axonometric projection of the circular hole, the cylinder, up on top of this here. So now what we need to do is we're going to divide this circle up into a number of points, because we had points for this corner and this one and this one. But for this circle we don't have any points. We need to create points on that circle. To do that, we're going to divide it up. Generally we divide it up into 12 parts, but we may not need 12 parts here today. So as we're looking in this direction, we're going to need the points here and here for the very widest part. So we can take a 45-degree line across the center, and that'll give me 2 points on the widest part of that. We also have, we could say, this point here and here, and we'll also take the other point going across it that way. So that gives me a number of points. Now I'm also going to divide this up with my 60-30. Just get a few more points. So that's going to give me a number of points. So we've got 1, 2, 3, 4, 5, and I'm missing 1. 6, 7, 8, 9, 10. So that gives me 10 points on this curve. So the number of points you have doesn't really matter. But now what I need to do is I need to locate these same 10 points up here in the elevation. So 1 is at the very widest point, so this is going to be 1. 6 is at the opposite side. So what we need to do is we need to find the distance from 1 to 2 across this way. And to do that, I'm going to take the 45-degree set square and draw a line across it like this. So that's going to show me the distance from 1 to here. From 3 and 9, it'll show me the same thing. So I see the distance from 1 into 3. There's the center. 4 across to 8 is the same. So 1 down to this line here shows me how far they are. And 5 and 7 the same. So what I can do now is I'm going to copy each of those distances. So from a known point, so I know the distance that 1 is. So I can copy distance into 2. 1 to 2. So this is point 2 and 8. Again doing the same thing, this time into the line joining 3 to 9. Uh, 4 to 8. So all this is the distance in that it is. So the distance, the left-right distance, I suppose you want to call it that, from 1 to the point 2, 8, 10, and the 1 to 3, 9, and 1 to 4, 8, and so on. So this is the final one that I need to measure. That's from 1 to 5, 7. You can measure it going the opposite way if you like. It doesn't matter. It's just so that you have a known point that you can measure all these points from. So the rest of this now is the same as every other piece that we've done with this. So we're just moving a point, projecting a point up into the axonometric view. So that's point 1. Project down point 1, the same point 1. That gives me a point up there. Go and do the same thing now for point 2. So point 2 is projected up. That's also projected down then from the elevation, giving me point 2. 10 can be done the same way. So 2 and 10. That's point 10. Next, do it with point 3, and so on. Continuing on doing each of these points. Working my way around. So almost there. So keep working my way around to join all the points up. 7 and 5 are on the same line. That's 7. 8 is on the same line from the elevation as 4. And finally 9 is on the same line from the elevation as point 3. So that gives me a number of points up on top of this. And now we just need to join them all up, drawing the best curve that we can. And that completes the curves. So just a quick recap on what happened here. Divided this circle up into a number of equal parts, or that they don't have to be equal, it just makes it easier if they are. Took the distances, the left-right distance, so 1 to point 2, 1 to point 3, 1 to point 4, and so on, and marked those same distances up here in the elevation. Then point 2 for example, was projected down along this way. Point 2 from the plan was brought up to meet, and they intersect at this point, giving me the point on the curve, same as where the other points were drawn. So that completes 2019 ordinary level B2.